the last part of the angles we want to talk about stems from making parallel lines. And we've talked about on the back, when you see the poster, parallel, perpendicular, and skew. We've talked about that. But we want to talk more about what happens when you have parallel lines and then you strike a line through both of them. And you're going to notice that there's several different types of angles that show up. And it's going to be a lot of definitions, but if you have it written down somewhere, that way you can take a look at it and build from there. As long as you know where to look, you'll be able to use the angles. So here's what we want. I'm going to start off with two parallel lines. And again, it doesn't have to be sideways. They can go up and down, on an angle. It doesn't matter. And what I'm going to do is strike one line down through both. This line is special because it crosses through a set of parallel lines. It has a special name. It's called a transversal. Trans means across or through. Transversal. So yes, you need to be aware of transversal. When you look at this picture, now ask yourself, how many angles are there? If you break it into pieces, you'll see there's a cluster up top. The cluster up top is very similar to the cluster down below. They match up. All the same angles are made up top as they are on the bottom. There are 4 angles up top. 1, 2, 3, 4. I'm just going clockwise. It doesn't really matter. 5, 6, 7, 8. There are 8 total angles, and you'll notice that certain angles match up because they're identical. What we're going to do is look at vertical pairs first. Remember, vertical angles are angles that are equal. They must be back to back. 2 is vertical with which angle? It has to be touching it. It must be back to back. That's right, 4. So what I'm going to do is list. 2 and 4 are verticals. What else are vertical angles? Well, 1 and 3. They're back to back. 1, 3. Those are vertical angles. No, that's not the bell to leave. That's the bell as I record. There's more verticals. 5 and 7, 6 and 8. Remember, the last thing with this is they're equal. Because they're vertical, that means they're equal. So, is 2 equal to 4? It is. Is 1 equal to 3? It is. Is 5 equal to 7? It is. And is 6 equal to 8? It is. So if I knew that this was 100 degrees, what would angle 2 be worth? That's right, it would also be 100 degrees. That's vertical angles. How many angles are formed? 8. 2 clusters of 4. A cluster here and a cluster here. Top cluster, bottom cluster. Same shape, different locations. The next angle is corresponding angles. Corresponding is this. If you remember, I did this with some classes, not all. Corresponding would be, if I do this, can you do the same exact thing so you correspond to me? It means you're pointing at the same part of your body. Now check, are you pointing at your left ear? Are you using your right index finger to point at your left ear? I'll turn around, should look like this, right? That's corresponding. Can you correspond to this? Can you correspond to this? Which hand is tapping? If you are corresponding, you have the same hand tapping as I do. If I reverse, which hand is rubbing your belly? It's the right hand. That's corresponding. If I flip and do this, or if I rub and pat, corresponding. Corresponding is the same location but in a different cluster. So, angle 2 corresponds with what? Angle 2 is in the same spot as which angle from this cluster? Well, take a look at it. This is in the top right corner of this cluster. What is in the top right corner in this cluster? 6. 2 matches up with 6. What does 3 match up with? 3 matches up with bottom left, which is in the bottom left, 8. 1. 1 matches up with what number from this cluster? 5. 1 and 5. 4 is left to match up with 7. Corresponding. Same location, different cluster. And yes, they are equal. So if angle 5 was 60 degrees, tell me another angle that would be worth 60 degrees. Well, what corresponds with 5? Angle 1 does. That means angle 1 is 60 degrees. Tell me a different angle that's worth 60 degrees. What about angle 7? Because angle 5 and 7 are what type of angles? They're back to back, which means they are vertical. So, notice how the ideas blend together. 5 is equal to 60, so is 7 equal to 60. What other angle is equal to 60? What does 7 correspond with? Angle 4. This is 60. Now why does that work? Because look at 1 and 4. Angle 1 and 4 are back to back, which are vertical. These two are equal. 60, 60, 60, 60. So notice how they pair together. The angle is a little tricky, but we have to again look at the definition or the words that were given and make sense of it. Two parallel lines. One line that strikes through both of them called a T. What does it stand for? Transversal, that's right. How many angles are formed? In this case I have 8. How many different clusters? 2 clusters. This cluster is identical to this cluster. We talked about vertical back to back. We talked about corresponding. The next type is alternate interior angles. Watch how this breaks down. Alternate. Different sides of transversal. So first of all, you have to name 2 angles that are on different sides of the transversal. For instance, is 1 and 4 alternate? Are they on different sides of the blue transversal? No. What about 6 and 7? Are they on different sides of the transversal? No, they are not. Name 2 angles that are on different sides of the transversal. 1 and 2, 4 and 3, 5 and 6, 8 and 7, 8 and 2, 8 and 3, 7 and 4, 7 and 5. So that's part of the definition. The other part is interior. Alternate interior angles. Interior. Inside the parallel lines. Whoops. 1 R, 2 L's. Inside the parallels. So you must find 2 angles that are on different sides, alternate of the transversal, different sides, and they must be inside the parallels. So which angles can I immediately cross off because they're not inside? I can cross off 8 and 7. I can cross off 1 and 2. So I'm only left with the inside angles. Inside the parallels. Alternate means they're on different sides. So let's find some. Angle 3 is on the right side of the transversal. What is its match? What is also inside the parallels but on the other side? Well, it's not 4, because remember they have to be equal. Equal in size. Alternate and interior. 4 is an obtuse angle, 3 is an acute angle. It has to be matched up with 5. 3 matches up with 5. What else do I have? Angle 6 matches up with angle 4. So in this case, 3 and 5 are alternate interior angles. 4 and 6 are alternate interior angles. Remember, they're equal. So if angle 3 was 50 degrees, so would angle 5 be 50 degrees. Our last type of angle is called alternate exterior angles. Very similar to what you just got done looking at. Two parallel lines. One line strikes through both of them, which is called a transversal. It is special because it has special properties. It makes 8 angles, 2 clusters that are identical. This cluster of 4 is identical to this cluster. So let's take a look. Alternate exterior angles. Alternate means different sides of the transversal. Simple enough, I need angles that are on different sides. Exterior, outside, like exterior paint, outside the parallels. So I'm looking for angles that are outside the parallels. Which angles can I immediately get rid of? The 4, the 3, the 5, and the 6. I only want the angles that are outside the parallels. Outside, outside. Okay, let's name some pairs that are opposite sides or alternate sides from each other. Let's start with 8. 8 matches up with 2. They're equal. They're both the same type of angle. They're both obtuse in this case. So if 8 was 100, what would the measurement for angle 2 be? Also 100. That leaves angle 7 and angle 1 to match up. 7 and 1. Alternate exterior angles. They are equal in size or congruent. They're on different sides of the transversal and they're outside the parallels.